today's class is on polar covalent bond and non-polar covalent bond. Polar covalent bond and non-polar covalent bond. Look at the example of CH4. Okay. CH4, all the four covalent bonds are slightly polar. Why? The electronegativity of carbon is 2.5 and that of hydrogen is 2.1. Carbon is more electronegative than hydrogen, therefore there accumulates slight amount of negative charge. All these bonds are polar. This is delta plus, delta plus, delta plus, delta plus. Previously it was written as delta 4 minus, but nowadays it is called only delta minus. So this compound is non-polar. The compound is non-polar, but the bonds are polar. Bonds are polar, though the polarity is very small. Okay. I repeat, methane is a non-polar compound as a whole. Look at the example of carbon dioxide. Electronegativity of carbon is 2.5. That of oxygen is 3.5. Therefore, both the carbon-oxygen bonds are polar. That means this is delta plus, delta minus, delta minus. But as the structure of carbon dioxide is linear, this is called bond moment. These two bond moments cancel each other. Therefore, the resultant dipole moment of carbon dioxide is 0. That is represented by mu. Okay. So the carbon dioxide molecule is as a whole a non-polar molecule. Oxygen bonds are polar. You are searching for an example of non-polar covalent bond. These type of bonds are non-polar, where the bond is between two same atoms. Is it alright? These are the examples of non-polar bonds. These are the examples of non-polar bonds. We especially emphasize on polar bonds and polar compounds. Okay? So it is very easy, the non-polar bonds and non-polar molecules. The molecule can be non-polar, although the bonds are polar. Look at the example CCl4. From Beer theory, The structure of CCl4 is tetrahedral. Each bond moments are represented by like this. Okay. The resultant of 4 bond moments, that means the resultant of 4 CCl bond moments become 0. That's why carbon tetrachloride is a non-polar compound. Do you understand, Abhija? Unmute yourself and tell me.
Yes, sir.
Okay. Stop. I am taking another example. NH3. The structure of NH3 from DSCPR is pyramidal. Okay. In NH3, this moment is for lone pair. Moment for lone electron pair. These bonds are polar, but the polarity is towards nitrogen. The resultant of 3 NH bonds is upward, plus the moment due to lone electron pair is like this, is equal to like this. This is the addition of vector. Okay. All these 3 vectors, the resultant is this, and this moment is due to lone electron pair. These 2 moments directed to same direction. That's why the resultant is greater than something better. Okay. So ammonia is a polar molecule. Ammonia is a polar molecule because where mu is not equal to 0. This is the example of ammonia. I am taking another example. In this case, this is CH3, CH2Cl, that means ethyl chloride. Okay? This group is electron donating, so it is oriented towards this direction. So hydrogen atom, this direction. for CH bond in this direction and for CCl bond in this direction. Resultant of these two is directed towards this, and these two like this. Here it is and here it is. So the resultant is like this. So two vector, one is in this direction and one is this direction. So overall direction will be in this direction. Okay. So CH3Cl2, in case of CH3Cl2, mu is not equal to 0. That's why this compound is also a polar compound. I am taking some simple examples. For the sake of Advija, but you are because you are the beginner. Suppose the molecule is here. Very simple molecule. Electron number of hydrogen is 2.1, that of chlorine is 3.0. Okay. So there is a electronegative difference of 0.9. That's why the bond moment is directed towards this direction. This is a very simple example of polar compound, because there is only one covalent bond. Okay. Similarly, all these are covalent. Polar covalent bond. HA, HCl, HBr, HI. Okay. Which one is the most polar and which one is the least polar? 4.0, 3.0, 2.8, 2 point something 2.5. In all these cases, hydrogen is 2.1. Okay. You see, mu equals to charge into distance. There is two factors. One factor is charge accumulated on two atoms, and another factor is distance. The multiplication of these two factors results the overall diagonal of the molecule. In case of hydrogen fluoride, the bond length is very small, but charge separation is highest. Just a minute. The dipole moment of HF is 1.91. 1.91. In this case, HF equals to হচ্ছে 1.91 dy. What is dy? I have to explain. In case of HCl, there is only 1.03 dy. Though the bond length is greater than in case of hydrogen fluoride, but the charge separation is such that the product of charge and the bond length somewhat greater in case of HF compared to HCl. Okay. Similarly, that means down the group of halogen group, all hydrides, mu decreases because of less charge separation. Though the bond length is greater and greater down the group. Okay. I am taking another examples. These are the simple examples. Sulfur dioxide. In case of sulfur dioxide, one bond is like this, another bond is like this, and this is directed towards this. Alright. So these two are the resultant of these two bond moments is downward, but the moment due to lone electron pair is upward. So the resultant will be somewhat less than as expected. Okay. So mu of sulfur dioxide is less than expected due to presence of lone pair, but it is a polar compound. It is not equal to 0. So you have to decide whether the resultant dipole moment of all bond moments and taking into consideration the lone electron pair, if the resultant dipole moment becomes greater than 0, in those cases, the molecule will be polar, and when mu equals to 0, it may be due to non-polar covalent bonds, it may be due to polar covalent bonds due to symmetrical charge distribution. I am taking another example of boron trifluoride. Okay? This is an interesting example. From Beer-Schmidt theory, we get the structure trigonal planar. Okay. So the bond angles are here. All three bond angles are here of value 120 degree. 120 degree. Okay. So if you consider this in this direction, the delta plus, delta minus, delta minus, delta minus, as because of fluorine is more electrolytic than boron. So all three bond moments cancel each other. It can be proved to vector summation if from one point the equal forces acts, resultant will be 0, because if you draw the parallelogram, the resultant of these two will be in this direction, and this amount in amount also same in magnitude and direction. Magnitude is same, but direction is opposite. That's why mu equals to 0 here. Alright. I am taking another example. Very simple example. Water molecule. What will happen? According to VSEPR theory, we get the tetrahedral electron pair geometry. That means if one hydrogen like this, another hydrogen like this, and lone pair is directed towards this and towards this. Okay. So these two are on the plane. We know the angle between two OH bonds are 104 degree 28 minutes. It has been discussed in PSC theory. So resultant of these two lone electron pairs is directed towards this direction, and this is in this direction and this is in this direction. So these are this direction and this direction. Resultant will be this, and that means this direction, and for lone pair this direction, it gets mu is greater than expected from only two OH bonds. Okay. So water molecule is highly polar. Mu of Y H2O is too much greater than 0. So water molecule is highly polar. Highly polar molecule. Advija,
Yes, sir.
I will take rest for just 5 minutes. Okay?
Okay, sir.
Stay online.
Hmm.
Why ammonia is more polar than NF3? Why NH3 is more polar than NF3? Look at the structure of NH3 and NH3. In case of NH3, the electron density is towards nitrogen. I am drawing like this. Because we know nitrogen is more electronegative than hydrogen. So electron density is accumulated on the nitrogen atom. So these three bond moments acts towards nitrogen, and the moment due to lone electron pair also directed towards this. That's why mu of NH3 is more than that of NF3. Now come to the NF3 molecule. In case of NF3, as fluorine is more electronic than nitrogen, the electron density is towards fluorine. That means the bond moment acts like this in opposite direction to the moment due to lone electron pair. That's why this is due to 3 NF bond moments and this is due to lone electron pair. So mu of NF3 will be less than mu of NH3. Is it clear to you? Is it clear to you, Abhija?
Yes, sir.
You are talking very loudly. Okay. What is your question? Any question? I will explain. Yes.
No, sir, what are this?
What is the question? Your?
Sir, there is no question at this moment, but if further there will be any question, then I will ask you.
Okay. I am talking some examples in which case all I will explain 3 cases. One is carbon dioxide, second is carbon disulfide, and third one is H2O. Out of these 3 molecules, which molecule is polar? CO2, CH2 and H2O. CO2, CH2 and H2O. Which one is polar? Tell me. I have already explained.
Sir, please repeat.
Out of these 3 molecules, there is carbon dioxide, carbon disulfide, and H2O. Which one is polar and which one is non-polar? It may be 1 or 2. Which compound is polar? Only one compound is polar here. We have discussed already. Can you explain? Is it tough to you? This is polar. And these 2 molecules are non-polar. Why? Look at the structure of carbon dioxide. Structure of carbon disulfide. And structure of water molecule already we have discussed. Okay. So this is polar due to 2 lone electron pairs and 2 bond electron pairs. These are bond electron pairs directed towards this, and this moment is due to 2 lone electron pairs, and addition of these 2 vectors become non-zero value. That's why H2O molecule is polar, but due to linear structure of carbon dioxide and carbon disulfide, in these cases the bond moments cancel each other. So in this case mu equals to 0, and in this case also mu equals to 0. But the bonds are polar. Maybe In case of carbon dioxide, the polarity is greater, but in case of carbon disulfide, the polarity is very very small because the electronegativity difference between carbon and sulfur is very very less. Okay. If I take an example of different type, bionuclear molecule, suppose this is an example. Will it be polar or non-polar? You know the electronegativity of carbon is 2.5 and that of hydrogen is 2.1. There is a slight difference between electronegativity. Okay. So this will be directed towards this and this will be directed towards this. These will cancel each other. And similarly, this will be directed towards this and this will be directed towards this. These two cancel each other. That's why ethylene molecule, this is an example of ethylene molecule, mu equals to 0, that is a non-polar compound, though the bonds are polar. Okay. Similar examples are acetylene. If we put another atom here, like this, will it be polar or non-polar? Will it be polar or non-polar? With chloroethene. Please tell me. Time is going, Abhija. Will it be polar or non-polar? If you not talk, I cannot understand what you are understanding or not. Only because of this C-cell bond, this molecule, in this case, mu is not equal to 0. This cancels this, but this and this are added. So mu is not equal to 0. That's why ethylene chloride.
No, but they are polar, non-polar. Like how to understand mu is 0 or not 0?
This bond moment cancels this. Is it alright?
Yes, sir.
But these are added. This bond moment and this bond moment in the same direction. Okay? So that will be added like this. That will be directed towards this. Is it clear to you?
Yes, sir.
Okay. It is too hot today. So I will end the class. Okay. So all the viewers are always welcome to my chemistry class. Good night. And all are present. It will go okay? All over. Okay.